Welcome to another episode, where we dive into one of the most critical health topics today, metabolic dysfunction. Our guest today is Dr. Pillai, with a decade's experience working in the NHS and a special interest in metabolism, mitochondrial health, and genetics. Before we begin, just a few words about our sponsor, Gene GPS UK. So Gene GPS is a functional genetic testing company that provides insights into your DNA, allowing you to take control of your health, fitness, and lifestyle. They are governed by very strict EU standards and offer the most detailed, up-to-date data. More importantly, they also have a high standard of keeping your genetic data secure and do not partake in the industry norms of selling your data for profit. The link to their webpage will be in the description. Dr. Pillai, great to have you today.
Thanks, Annabelle. It's great to be here. I'm so glad to be speaking to our audience about metabolic health, which is often trivialized in modern reactive medical practice. Understanding it better is vital to win the fight against what I call the blind pandemic.
I agree. I like the term blind pandemic. It almost entails a sense that people just don't seem to grasp the gravity of the issue and are happy plodding along the way they are, when in reality, something untoward is waiting for majority, just around the corner. So, let's start with metabolism itself. We hear that word a lot, but what does it mean? And how does metabolic dysfunction play into chronic diseases?
Metabolism is essentially how our cells convert food into energy. When it's functioning properly, the energy produced powers everything from muscle contraction to brain function. But when metabolism goes wrong, what we call metabolic dysfunction, it leads to issues like fatigue, inflammation, obesity, and chronic diseases. In fact, 1 in 3 adults in the UK are affected by metabolic syndrome, a condition that significantly increases the risk for heart disease, stroke, and type 2 diabetes. A 2021 study in Cell Metabolism linked poor metabolic health directly to increased risks of these diseases.
That's a staggering number. And it's no wonder we hear so much about chronic diseases like heart disease, obesity, and diabetes. How central is metabolism to these conditions?
Metabolism is the foundation of these conditions. For example, 63% of adults in England are overweight or obese, a key risk factor for metabolic dysfunction. When your body doesn't properly process glucose or fats for energy, it throws your entire system out of balance. This dysregulation leads to insulin resistance, weight gain, and a greater risk of cardiovascular disease. A Lancet study from 2020 highlighted how metabolic dysfunction is one of the major drivers behind most chronic diseases.
Now, you've spoken a lot in the past about mitochondrial health in connection with metabolic function. Could you explain the link between the two?
Absolutely. Mitochondria are the powerhouses of the cell, responsible for energy production. When your mitochondria are healthy, your cells are able to efficiently convert food into energy. But here's the kicker. More than half of UK adults report daily fatigue, which could be linked to mitochondrial dysfunction. As we age or experience metabolic dysfunction, mitochondrial efficiency decreases, leading to not only fatigue, but also weight gain and a host of metabolic disorders. A 2021 Nature Metabolism study found that enhancing mitochondrial function can improve metabolic health, reducing the risk of chronic diseases and improving overall longevity.
So, focusing on mitochondrial health is key to keeping our metabolism in check?
Exactly. Improving mitochondrial efficiency through things like regular exercise, fasting, and reducing oxidative stress can make a huge difference. There's even emerging evidence that cold exposure and certain supplements can enhance mitochondrial function.
That's fascinating. Let's switch gears and talk about something even more cutting edge: genetics and methylation. How do our genes play into metabolic health?
Our genes are the blueprint of our metabolic potential, but how those genes are expressed is just as important. This is where methylation comes in. Methylation is a biochemical process that affects how certain genes are turned on or off. Around 1 in 4 people in the UK carry a variation of the APOE gene, which increases their risk of heart disease. A 2020 study in epigenetics found that poor methylation patterns are linked to diseases like diabetes and cardiovascular issues. Understanding your genetic predispositions can help you take preventative measures before these conditions even develop.
So methylation essentially influences whether our genes help or harm our metabolism.
Exactly. Think of methylation as a dimmer switch for your genes. When methylation is optimal, your genes work in harmony to support health. But when it's disrupted, due to poor diet, toxins, or even stress, it can increase your risk of metabolic dysfunction. For example, genes responsible for inflammation or fat storage might get turned on more than necessary, contributing to obesity or chronic diseases. In fact, a 2020 study in Aging Cell found that poor methylation patterns can shorten your lifespan by up to 10 years.
Can genetic testing help us understand how methylation might be affecting our health?
Absolutely. Genetic testing, especially tests that look at methylation markers, can give us deep insights into how well our body is handling metabolic processes. It's like getting a roadmap of your own metabolic health. For example, if you have a variant in the MTHFR gene, which affects folate metabolism and methylation, you may be at higher risk for cardiovascular disease. The good news is that early identification of issues like this allows for tailored interventions, whether it's specific vitamins like methylated B12 or lifestyle changes, or even how one might go about exercising to support optimal gene function.
That sounds like a powerful tool for prevention. Are there specific methylation markers we should be looking at when it comes to cardiometabolic risks?
Yes, definitely. The MTHFR gene is one key marker, and another important one is ApoE, which is associated with lipid metabolism. A 2019 study in Circulation showed that people with certain variants of ApoE have a higher risk of heart disease. By understanding your genetic makeup, you can take early action, long before symptoms like high cholesterol or blood sugar become a problem.
And all of this ties into longevity, right? So how does early intervention in methylation and genetics impact our lifespan?
Absolutely. Optimizing methylation and addressing genetic risk factors early can have a profound impact on health span and longevity. Rather than waiting for chronic diseases like type 2 diabetes, which already affects over 4 million people in the UK, you can make adjustments to reduce your risk. By targeting these factors early, before symptoms even appear, you're essentially giving yourself the best shot at a longer, healthier life.
This is incredible information, Dr. Pillai. So, to sum it up, improving mitochondrial health, understanding genetic predispositions, and optimizing methylation are foundational for preventing metabolic dysfunction and improving longevity.
That's right, Annabelle. It's a holistic approach. Mitochondrial function, hormonal balance, blood sugar control, and the epigenetic factors of methylation, all working together. With nearly 160,000 deaths from cardiovascular disease every year in the UK, addressing these early can significantly reduce your risk of metabolic diseases and help you live a longer, healthier life.
Thank you so much for breaking this down for us today, Dr. Pillai. For our listeners, remember, metabolic health is within your control, and understanding your genetics and methylation is the first step to optimizing your health span.
Thank you, Annabelle. It's been a pleasure.